GenAI and MLOps Part 14. This episode has 14 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Kubeflow KDD. When would you use KDD for hyperparameter tuning, and how would you control search cost, parallel trials, metrics, and early stopping? Here's a strong way to approach it. Use KDD when manual tuning is too slow and the model has a clear objective metric such as validation accuracy, F1, or loss. Limit cost by bounding the search space, max trials, parallel trials, GPU requests, and experiment duration. Expose metrics from the training job consistently, and use early stopping so weak trials release resources quickly instead of burning GPU time. Nice. Let's continue. Question 2. Kubeflow model serving. How would you serve models from Kubeflow using Kserve, Canary releases, autoscaling, GPU support, and rollback? Here's a strong way to approach it. Use Kserve inference service resources to deploy model servers with explicit model artifact URIs, resource requests, autoscaling settings, and health checks. Roll out new versions with Canary traffic splits or separate revisions. Monitor latency, error rate, model quality, and GPU utilization, and keep the previous model artifact and serving config available so rollback is a quick traffic shift or manifest revert. Great. Moving on. Question 3. Kubeflow CI or CD. How would you integrate Kubeflow pipelines with GitHub Actions, Jenkins, Cloud Build, Argo CD, or GitOps? Here's a strong way to approach it. Use CI to test component code, build and scan container images, push them to artifact registry, and compile or version the pipeline spec. Use CD or GitOps to promote pipeline definitions and serving manifests through environments. Trigger pipeline runs with approved parameters. Gate promotion on evaluation results, and let Argo CD manage long-lived Kubernetes resources such as Kserve services and platform config. Alright, next question. Question 4. MLOps architecture. How would you design an end-to-end production MLOps platform from data ingestion to monitoring and retraining? Here's a strong way to approach it. Start with version data ingestion, validation, feature engineering, training, experiment tracking, evaluation, model registry, deployment, monitoring, and retraining. Each stage should capture lineage, code version, data version, artifacts, metrics, owner, and approval status, with CI or CD automation, IAC, least privilege IAM, observability, rollback, and cost controls wrapped around the whole life cycle. Let's keep going. Question 5. MLOps lifecycle ownership. Where do data scientists, ML engineers, platform engineers, SREs, and security teams own different parts of the model lifecycle? Here's a strong way to approach it. Data scientists usually own experimentation, feature hypotheses, and model quality. ML engineers productionize training, packaging, evaluation, and serving. Platform engineers provide reusable pipelines, infrastructure, registries, and deployment patterns. SREs own reliability practices such as slows, monitoring, incident response, and rollback. Security owns IAM, secrets, supply chain, privacy, and compliance controls. The handoffs must be explicit so production issues do not fall between teams. On to the next one. Question 6. MLOps CI or CD or CT. How would you design continuous integration, continuous delivery, and continuous training for ML systems? Here's a strong way to approach it. CI should test code, data contracts, pipeline components, containers, and model serving APIs. CD should promote versioned artifacts through staging and production with evaluation gates, approvals, canaries, and rollback. CT should retrain from scheduled or trigger-based signals, but promotion still needs validation against baseline or champion metrics so automated retraining cannot silently degrade production. Good. Here's another one. Question 7. MLOps data validation. What data quality, schema, freshness, and anomaly checks would you add before training or inference? Here's a strong way to approach it. Validate schema, required columns, types, ranges, null rates, duplicate records, category drift, feature freshness, volume anomalies, and referential integrity before training or inference. For production, fail fast on hard contract breaks, warn or quarantine suspicious batches, and log validation results as pipeline artifacts so bad data is caught before it creates a bad model or bad predictions. Nice. Let's continue. Question 8. MLOps model evaluation gates. What offline, online, business, fairness, latency, and reliability gates should a model pass before production? Here's a strong way to approach it. Offline gates include accuracy, precision or recall, calibration, regression metrics, robustness, and comparison against the current champion. Online gates include canary or shadow results, latency, error rate, resource usage, and business KPIs. For responsible production use, also check fairness, explainability, data coverage, security, and rollback readiness before allowing promotion. Great. Moving on. Question 9. MLOps monitoring strategy. How would you monitor model quality, data drift, concept drift, latency, errors, feature freshness, and business impact? Here's a strong way to approach it. Combine service metrics such as latency, throughput, error rate, and resource usage with ML-specific signals such as feature distributions, prediction distributions, data drift, training serving skew, delayed ground truth quality metrics, and business KPIs. Use thresholds with minimum sample sizes and persistence windows. Route severe user impact issues to paging, and send lower severity drift to review workflows to avoid alert fatigue. Alright, next question. Question 10. MLOps retraining strategy. How would you decide between scheduled retraining, trigger-based retraining, manual retraining, and champion challenger updates? Here's a strong way to approach it. Use scheduled retraining when the business has predictable data changes, trigger-based retraining when drift or performance degradation is measurable, and manual retraining for high-risk models where human review is required. Champion challenger works well when a candidate can be evaluated safely against the current model. In all cases, retraining should produce a candidate, not automatically override production without evaluation gates. Let's keep going. Question 11. MLOps incident response. A production model starts giving bad predictions but infrastructure metrics look healthy. How would you investigate and mitigate? Here's a strong way to approach it. Treat it as an ML incident. Confirm impact with prediction samples and business metrics. Compare current inputs against training baselines. Check feature freshness, upstream data pipelines, schema changes, model version, recent deployments, and ground truth feedback. Mitigate by rolling back to the previous model, disabling risky features, routing to rules or manual review, or reducing traffic while preserving logs and artifacts for root cause analysis. On to the next one. Question 12. MLOps governance. How would you make models reproducible, auditable, explainable, secure, and compliant across teams? Here's a strong way to approach it. Require every production model to have lineage linking data, code, pipeline run, parameters, metrics, artifacts, approvals, and deployment history. Add model cards or documentation. Explainability and fairness checks where relevant. Least privilege access, signed or scanned containers, audit logs, retention policies, and approval workflows so governance is built into the pipeline rather than handled manually after deployment. Good. Here's another one. Question 13. MLOps cost and reliability. How would you balance GPU cost, batch versus online serving, autoscaling, slows, and rollback for production ML workloads? Here's a strong way to approach it. Classify workloads by latency and criticality. Use batch prediction for offline work, online endpoints only when users need synchronous responses, and GPUs only when CPU or smaller models cannot meet slows. Right-size accelerators. Use autoscaling and quotas. Monitor utilization and cost by model or team, and keep rollback simple through versioned model artifacts and canary deployments so reliability does not require uncontrolled over-provisioning. Nice. Let's continue. Question 14. MLOps situation. Bad model release. A new model version passed offline tests but hurts business KPIs after deployment. What do you do in the first hour? Here's a strong way to approach it. First, stabilize. Pause the rollout, reduce or shift traffic back to the previous model, and confirm the KPI drop is real rather than a dashboard or attribution delay. Then compare canary segments, prediction distributions, feature values, model version, and recent upstream data changes. Preserve evidence, communicate impact and mitigation, and after recovery add stronger online gates, shadow testing, or business metric canaries so offline metrics are not the only release signal. Great, moving on. That wraps up this episode. Nice work practicing, and see you in the next one.